Almost everyone has heard of standard deviation and variance, but I'm sure you're wondering, why do people always mention these when talking about statistics or distributions? If you are curious, join me today to find the logic behind standard deviation and variance. Before we look into standard deviation and variance, we should first understand how statistical distributions work. A statistical distribution describes how values are arranged across possible outcomes, including where they are concentrated and how frequently they occur. The average, or mean, tells us where most of the data lies. However, just knowing the mean does not help us understand and fully describe the data. A nice analogy is body weight. If someone told you they weigh 80 kgs, you couldn't immediately tell whether that is overweight or not because you are missing context. You don't know their height, their gender, or their age, or any other factors. That single number on its own doesn't give you the full picture. Similarly, there are many distributions which could look very different, but all have the same mean. For example, this one, imagine it has a mean of 10, and this one, maybe it also has a mean of 10, but it looks very different from each other. That's where standard deviation and variance comes in. These two values describe how spread out the data is around the mean, and allows us to better describe and visualize the data. Although variance might seem like a simple concept, it's important to understand what it actually means in practice. We often think of the mean as what we expect to happen, but most of the time, individual outcomes don't hit that exact value. What matters is how far off they tend to be. Think of it this way. If outcomes are tightly clustered around the mean, data is predictable. You expect most of the data to all fall around here. But if there is a high variance, with the graph looking a bit more like this, outcomes can differ a lot from what you expect. So instead of all in the center, maybe there's ones that can go all the way out on the sides. And that unpredictability is what we think of as risk. Variance is simply the measure that captures how far outcomes stray from the mean, and therefore how much risk is involved. Let's look at what variance is first. Variance measures the squared distance of each data point from the mean. This means we look at how far each data point is from the mean. Then we square the distance. So it would look like this to square it. And then we find the average of all those distances, which is what we're doing here with this expected value. Now, I bet you are wondering, why do we need to square the distance? Isn't it so much easier to find the average of just the distance? Surprisingly, it's not actually easier to find the average of the distances. This is because we are looking at all the data points around the mean. If we collect all the distances, we would find that the positive and negative distances would cancel out and give a misleading result. Although we could potentially just use the absolute distances, squaring it is actually a lot more mathematically convenient. It also has another useful feature. Because larger deviations are more concerning than small ones, we want them to have a greater influence on our measure of variance. Squaring does exactly that, since when you square a large number, the result grows disproportionately, meaning outliers or extreme data points have a much larger impact on the variance than small deviations do. Remember how I mentioned that variance is related to risk? This is exactly why squaring matters. It amplifies that outcomes are far from the mean, which in turn signals a higher risk. Now let's have a look at standard deviation. Standard deviation is actually this symbol. You probably have noticed, hey, isn't that the square root of the variance symbol? You are correct. By square rooting the variance, we can find the distance from the mean but with normal units. What do I mean by normal units? So the unit for variance is actually squared, which is also why you see a square here from when we were looking at how to find the variance of one data point. This means that if we were working in centimeters, the variance would be centimeters squared. Or if the data points were measured in dollars, the variance would be dollars squared. So when we find the standard deviation and we square root the variance, it means that we are going from centimeters squared to just centimeters, or from dollars squared going to just dollars. So this here is the variance, and this here is the standard deviation. The standard deviation measures the typical distance of values from the mean. If variance measures risk mathematically, standard deviation expresses that risk in real-world terms. If you enjoyed this video and want to see more content like this, don't forget to like and subscribe. See you next time!